this model that you see is a suggestion for one way to think through a math problem. It is a very solid problem-solving process. You start by writing a verbal model. So write it out using words, then put labels into it, then put the numbers into the problem, solve it, and then answer the question. So this is a valid problem-solving strategy if necessary. Do I expect you to use this strategy in this order every single time? No. I want you to get the answer. And if you can get the answer somehow, get the answer. The only completely unacceptable way to get the correct answer is to look at your neighbor's paper and write their answer down on your paper. That would be called cheating. So don't cheat, but however you get to the answer is totally fine with me. Here's our first problem. The bullet train runs between the Japanese cities of Osaka and Fukuoka, a distance of 550 kilometers. It makes no stops. It takes 2 hours and 15 minutes to make the trip. What is the average rate of the bullet train? Okay, I see distance, time, and rate, and I feel like there's an equation relating distance, rate, and time. Do you remember that formula? Distance equals rate times time. So if you remember that formula, this is extra helpful. So labels, let's do D equals RT. It is also helpful to stick some information in here. Our distance is in kilometers. Our time, it says hours and minutes, so we could convert that to hours or we can convert it to minutes. Our rate, does kilometers per hour make more sense or does kilometers per minute make more sense? Kilometers per hour. So our rate is probably going to be kilometers per hour. That means our time needs to be in hours. The labels that we're using are kilometers and hours. So we're going to take 2 hours and 15 minutes and convert that into just hours. So it's 2 point something, 2.25. 15 minutes is a quarter of an hour. If you need help with that, remember you can do 15 divided by 60. That would give you that 0.25 or the 0.25. All right, our distance. Our distance is 550 kilometers. And you can go ahead and write the labels in there if you want to. We don't know the rate. The rate is the thing that we don't know. That's what we're trying to find. Our time is 2.25 hours. Once we have it written this way, how do we solve this? Divide by 2.25. And I'm going to go ahead and write that 2.25 hours, because then it really shows us what our answer is going to be. So grabbing our calculator, 550 divided by 2.25, 244.4. And then our label is kilometers per hour. Don't forget to do this last step. Even if you take a shortcut to get to the answer, answer the question. The question is asking us, what is the average rate of the bullet train? The average rate is 244.4 kilometers per hour. Okay, I want you to take a minute. Number 2 is not really like number 1. You could do this similar to number 1. I just want you to read this and try something. The interesting thing about this problem is that the problem doesn't actually start until here. Find the flow rate if a shower head fills a 22-gallon bathtub in 9.5 minutes. So this is like question number 1. We're talking about a shower head filling up a bathtub. Find the flow rate if it fills a 22-gallon bathtub in 9.5 minutes. Once you're done with that, then it's going to ask you the second question referencing this previous information. So this part is actually question number 2. Okay, it fills a 22-gallon bathtub in 9.5 minutes, and I see that this flow rate up above, it says 2.5 gallons per minute. So I'm thinking that I'm going to do 22 gallons. It did that in 9.5 minutes. If I divided 22 divided by 9.5, that would give me gallons per minute. So that's how I'm going to do this problem. 22 divided by 9.5, 2.32 gallons per minute. For part 2, they're saying that the maximum flow rate advertised is 2.5 gallons per minute. So the question is our flow rate of 2.32 gallons per minute within the advertised limit? Yes. It can be up to 2.5 gallons per minute. It did it in 2.32 gallons per minute, so yes, it's within that limit. All right, next is looking for a pattern, and this might be more comfortable for some of you because it's kind of like y equals mx plus b. Basically, this is an XY table. The table gives the heights to the top of the first few stories of a tall building. Determine the height to the top of the 15th story. On these problems, there are probably 7 different ways that you could get the right answer. I don't care which way you pick. The first thing that I like to do is look for a pattern. So between 20 and 32, how does it change from 20 feet to 32 feet? Plus 12 feet. How does it change from 32 to 44? Plus 12 feet. 44 to 56. Plus 12. And plus 12. There is a constant rate of change. Constant rate of change is also known as a slope. So if we were to graph this, the slope of the graph would be 12. We're increasing by 12 feet on each floor. So we could say y, or h, the height to the top, equals 12 times the number of stories. But if I just left it like this, the first story should give me 32 feet. 12 times 1 is not 32. How do we make 12 times 1 get up to 32? What else do we need? Plus 20. So it's kind of like we're thinking of this step as the 0th floor. That's our starting amount. So we're starting at 20 feet and then increasing 12 feet each floor after that. If we create a cool formula like this, then to find the height to the top of the 15th story, you just plug 15 in. So grab your calculator. 12 times 15 plus 20. It is 200 feet at the top of the 15th story. Okay. I know I started with 20. I added 12 each time, so there's my first floor. I added 12 again. There's my second floor. Could you just hit enter enough times until you got to your 15th floor? Absolutely. 44, that's my second floor. Third, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11, 12, 13, 14, 15. You absolutely could just hit enter in the calculator enough times to get up to the 15th floor. If you're asked for the 15th floor, that's not a big deal. If you're asked for the 147th floor, you might be sitting there hitting enter a few too many times. That's where the formula is a little bit nicer. I want you to work on number 4 on your own. See if you can figure out how high above the stage are the seats in row RR. Okay, I wrote out 2 options that I have heard today. The first option is doing exactly what we did in number 3. The difference between the height in each column is 1.25 feet. So 1.25 times x, and then our starting amount was 18. But if 18 is the starting amount, that means that the x value for that one is 0. So if row AA is 0, then row RR would be 17. So if you wanted to find the height for row RR, you'd have to plug in 17. The way that you could avoid that is you could think about, okay, if row AA, if I want that to be x equals 1, then if I were to go backwards 1.25, I would be at 17.75. So when x is 0, the height would be 17.75. So your starting amount, 17.75. Then row RR is x equals 18. So how you solve the problem might be different than how your neighbor solves the problem, and as long as you each know which row is RR, you should be fine. Another way to do this is just type it in your calculator or draw it out or write out the pattern until you get to row RR. Just pointed out to me that sometimes my mental math is awful. If you subtract 1.25, that would make this 16.75, which would make this right here 16.75. Then if you plugged in 18, you would get the correct value. It's really good when my students watch my math because sometimes I make mistakes.